Couple of just examples here. Uh, Given Army reports that the distribution of head circumference among soldiers is approximately normal with a mean of 22.8 inches and a standard deviation of 1.1. What's the probability that a randomly selected soldier's head will have a circumference that is greater than 23.5 inches? Okay, so how many people are we talking about in this? We're looking at a single soldier's head, and I want to know whether or not his head is larger than 23.5. Okay, so this is another calculator skill, and we're going to look at norm CDF, and we'll type in those parameters and see what the probability. Okay, so from our calculator, we want the distributions menu. So we're going to go to norm CDF, and we're going to input in what it is telling us here. So we got a mean of 22.8 and a standard deviation of 1.1. So we'll get to the upper lower in a second. Let me get that mean typed in of 22.8 and a standard deviation of 1.1. Okay, and then the question is asking that a randomly selected student will have a circumference that is greater than 23.5. So I want I want it bigger than 23.5. So my lower estimate, my lower bound is 23.5. And then I want infinity here, so I want something really, really huge. Okay, so the infinity we get by typing in 1, and then we want this EE, so second, comma, 99. And then I'm going to hit enter. So that's what it looks like from the home screen. And then when I hit enter, I get 0.2622. So about 26% of the time, I would expect someone with a big head, basically, is what we're talking about. 22.8 being a normal head, 23.5 is a big head. So given those numbers, 26% of the time I would expect it to be larger than 23 probability is. And just like we saw in the calculator, we get a probability of 0.2623. Okay, so we're going to sort of change the question. The question now is, the first time it was if we just grab one soldier, what's the likelihood of it being larger than 23.5? Now we're going to grab 5 soldiers. We're going to take 5 random individuals, and we're going to measure their heads and add them up and divide by 5. And the question is, now what percent of a sample size 5 would we expect it to be bigger than 23.5? So that does change. Our mean stays the same as it was in the previous example, but our standard deviation is now divided by the square root of our sample size, so in this case square root of 5. And so when we type in those parameters in the calculator, so let me get that loaded up. All right, we're going to go right back to norm CDF, and this time we're going to go back to same numbers. So the 23, so we want above 23.5. The only thing that's going to change this time is instead of 1.1, it's going to be 1.1 divided by the square root of 5. It goes back to that sample standard deviation changing. And I believe we can just type in divided by square root of 5, and our calculator should be okay with that. And when I hit enter, I get a probability of 0.077, which is about 7, almost 8% of the time. I would see something like this. And just like the calculator showed us, we get a probability of 0.0774. Now, hopefully we noticed that it's a smaller probability. So you got to think, why? Why is it smaller? Well, we've, let me back up there. Sorry, I got excited with the clicking there. Why is the probability a smaller number? Well, if it was, let me go even back further here. So if the likelihood of one guy having a huge head is 26%, what's the likelihood that I can have 5 guys with huge heads? Well, that gets smaller because we've got more people that have to have larger heads, and so that decreases down to 7%. So in real life, that actually does make sense. As we start gathering more people together, the likelihood of them being extreme sort of decreases. Suppose a team of biologists have been studying the Pinedale Children's Fishing Pond. Let X represent the length of a single trout taken at random from the pond. The group of biologists has determined that the length has a normal distribution with a mean of 10.2 and a standard deviation of 1.4. What's the probability that a single trout taken at random from the pond is between 8 and 12 inches? Okay, so a couple things they tell us. They tell us it's normal distribution. So we know the population is normal, so any sample size should be normal. They also tell us the mean of the population is 10.2 and the standard deviation is 1.4. Okay, so the question then is, what's the probability that if I grab a single fish that it's somewhere between 8 and 12? Well, that's a norm CDF function again, so we're going to go to the calculator and figure that out. All right, we're going to go right back to norm CDF. Just hanging out there all day, it seems. Okay, so this time we want the fish, the single fish between 8 and 12. So I'll change the lower to 8 and the upper to 12. And it gives us a mean of 10.2 and a standard deviation of 1.4. And then I hit enter, and I get a p-value or probability of 84%. So 84% of the time I'd expect to see something like this. And just the calculator then told us it's 84% of the time I would find something between 8 and 12. Okay, so most of the time I would expect that. Let's change the question. Let's say I'm going to grab 5 trout, and I'm going to add them up and divide by 5. What's the likelihood that it's still between 8 and 12? Well, in the fact that we grabbed a sample now of size 5, what changed about our problem? Our mean stayed the same, but our standard deviation got smaller. We would reduce it by, or divide by the square root of 5. So let's go to the calculator and get that. So we're going to go right back to norm CDF, so back under distributions. And everything stays the same except our standard deviation. We grabbed a sample of size 5, so I'm going to divide by the square root of 5. And I get a higher probability, so 0.9977. And again, we get a probability of 0.9978. Okay. Now, hopefully we noticed it got bigger. Okay, so you think about that for a second. 8 and 12 is not very off. It's a pretty common fish length, given that the mean is right about the center, about 10.4. So finding one fish between that isn't too hard. Finding 5 of them is even easier to find. I mean, I might have one extreme fish, but the other normal sized fish would sort of balance out that extreme fish. Okay, next question then, what sample mean would be at the 95th percentile? Again, assuming we're looking at a sample of size 5. Okay, so we got to think back. It's been a while since we've done percentile, but if I have 95th percentile, what calculator function am I actually referring to? And that would be inverse norm. So we want to go to our inverse norm menu, and then we'll type in the parameters that it's asking for here, and then come back and figure out. So this time, instead of norm CDF, we actually want inverse norm. And inverse norm is going to ask for the area. If I want the 95th percentile, I want the bottom 95. So I'm going to put 0.95 for the area. I'm going to go ahead and input the mean and standard deviation of our trout. So I believe our mean was 10.2 and our standard deviation was 1.4. So 10.2 there and 1.4 for standard deviation. This is sample size 5, so I do want to make sure I divide by the square root of 5. And then I'll hit enter, and calculator does the magic here, and we get 11.2 as our answer. And we, just as a calculator, we got 11.23. Okay, do another one. A soft drink bottler claims that on average, cans contain 12 ounces of soda. We'll let X denote the actual volume in a randomly selected can. We want to know if they're cheating us. Suppose that the population is normally distributed. Okay, that's great. Means I don't have to worry about sample size being normal. I expect them all to be normal. And I get a mean of 6.16 ounces. So 16 cans are randomly selected, and I get a sample mean of 12.1. Okay, so we got a sample size 16 and the sample mean is 12.1. What's the probability that the mean of 16 will exceed 12.1 ounces? Okay, so what's the likelihood of me expecting something like that? Okay, so let's go to our calculator and let's figure out, we've got a sample standard deviation, so we got to convert that 0.16 into sample. All right, so going back to norm CDF, and let's take a look here at our numbers. Let's see. Okay, so we got standard deviation of 0.16. Okay, so I'm expecting it to be 12. I want to know the likelihood of 16 cans being larger than 12.1. Okay, so lowest. Let's go to the mean, I guess. Well, the mean is probably easier to talk about. I expect. Let's see, it's got to be 12.1 or bigger, so the upper value would be infinity. So 1 e to the 99. 12.1 would be the lower. The mean would be 12. And the standard deviation, we have 0.16, but that's population. We want a sample standard deviation. So there's 16 cans. So that's divided by the square root of 16, which I know is 4, but I might as well type that in. All right, so then I'll hit enter there. And we get a probability of 0.006. And we got 0.0062. So pretty unlikely that we'd get 16 cans that would be over, they wouldn't give us too much soda. That's the point of all this.